Hello friends, I hope you all are fine. So, today we'll discuss about an interesting topic about how to learn Krebs cycle with a twist or a trick. Before that, I would like to say a few things about Krebs cycle. In 1937, Hans Adolf Kreb and William Arthur gave the name Krebs cycle. It is occurring in the mitochondria of the cell, where the cell goes through aerobic respiration to produce energy. During this process, it gives out carbon dioxide and water. Krebs cycle or TCA cycle or citric acid cycle is also called aerobic biodegradation. It's a catabolic process of acetyl-CoA. So, shall we learn the shortest, sweetest, and the most informative way of learning Krebs cycle? Yes. Let's start. Today we will learn how to remember Krebs cycle. Now we will learn this Krebs cycle in the form of mnemonics. Many children ask me, what is mnemonics? Mnemonics is nothing but you use the first letter of any pathway or any table where you will use the first letter to make a simple sentence which can be easy to remember. So when you remember that sentence, you will be able to crack the entire pathway without any mistake. So the brain will find very easy to understand or remember the entire cycle without any confusion. So here's the trick. Let me teach you Krebs cycle with a funny sentence. Austin cow is alpha, some super funny melody opera. Now, isn't this sentence very funny and simple to remember? If you're going to remember this sentence, it's easy to crack the entire Krebs cycle in no time. Let's crack it. Austin cow is alpha, some super funny melody opera. Austin A for acetyl-CoA enzyme, which is acetyl-CoA, which is required to get into the citric acid pathway or the Krebs cycle. So Austin, acetyl-CoA. Next, cow, C for cow, C for citrate. Okay, so acetyl-CoA, which gets into the Krebs cycle, it starts with citrate. Now the citrate will become isocitrate. So next is what is? Austin cow is iso. Okay. Now Austin cow is alpha. Alpha is nothing but alpha ketoglutarate. Is it this simple? Next, some SU is nothing but succinyl-CoA. Super again succinate. Funny Fu is nothing but fumarate. Melody, I know it's not melody, I just made it melody since Ma it is malate. Alright? Opera O oxaloacetate. Simple. Austin cow is alpha, some super funny melody opera. If you remember this, remember the entire pathway where acetyl-CoA enters into citric acid pathway where citrate converts into isocitrate, isocitrate to alpha-ketoglutarate, alpha-ketoglutarate to succinyl-CoA, succinyl-CoA to succinate, succinate to fumarate, fumarate to malate, malate to oxaloacetate. So it doesn't end here. I will show you that using the same mnemonics, you can always remember the following components or the following citrate, isocitrate, alpha-glutarate and all, and the enzyme also can be remembered simultaneously. Now let me show you that. So let's see here the first half. Here if you see, you have Austin, which is, I represent A for acetyl-CoA. So cow is citrate, and what is required citrate to break down to isocitrate? Aconitase is the enzyme. IS is isocitrate. Isocitrate requires isocitrate dehydrogenase to give alpha-ketoglutarate. Alpha is already represented here, alpha. So alpha-ketoglutarate requires alpha-ketoglutarate dehydrogenase to produce succinyl-CoA. Now this succinyl-CoA requires succinate thiokinase, or you can say succinyl-CoA synthase. Okay, succinyl-CoA requires succinate thiokinase or succinyl-CoA synthase. So did you crack the first 4 enzymes required in breaking down the pathway or for the pathway? Okay, so Austin cow is alpha sunk, so it requires, if you remember this first 5, you're going to remember acetyl-CoA, citrate, isocitrate, alpha-ketoglutarate, succinyl-CoA. From here it's very easy to remember the corresponding enzyme required. It's very simple. That is, citrate requires aconitase. Okay, only citrate is something having a different enzyme, but it is aconitase. Citrate uses aconitase to produce isocitrate. Isocitrate requires isocitrate dehydrogenase to produce alpha-ketoglutarate. Now alpha-ketoglutarate requires alpha-ketoglutarate dehydrogenase to produce your succinyl-CoA. Now the succinyl-CoA will use succinate thiokinase or your succinyl-CoAs to produce your succinate. Now we'll see how we can produce how we can go ahead with succinate. So we already seen that your succinyl-CoA requires succinate thiokinase or succinyl-CoA synthase to produce succinate. Okay. Now succinate requires succinate dehydrogenase to produce fumarate. Okay. Now I have already told you, super funny melody opera. So SU is for succinate, FU is for fumarate, MA is for malate, O is for oxaloacetate. See, I just made it melody, not melody, because I wanted MA to remember malate. Alright. So succinate uses succinate dehydrogenase to produce fumarate. Now fumarate uses fumarase enzyme to produce your malate. Your malate uses malate dehydrogenase to produce your oxaloacetate. Now oxaloacetate uses citrate synthase to produce your citrate. Now citrate, where it requires again the enzyme acetyl-CoA. Now acetyl-CoA is required again to get into your Kreb cycle, where your citrate will undergo the pathway again to produce your energy, that is your ATP molecule, plus water plus carbon dioxide. Now this entire cycle goes through in your mitochondria, because mitochondria is called the powerhouse of a cell. So I hope you remember the mnemonics and simultaneously able to crack down your Krebs cycle. If you can remember your Krebs cycle, it's very easy to remember the corresponding enzyme required to produce the following products. Now here, if you remember, here this particular mnemonics not only helps you to crack down the pathway, but it also helps you to remember the corresponding enzyme. SU is for succinate, succinate dehydrogenase. FU is for fumarate, fumarase. MA is for malate, malate dehydrogenase. O is for oxaloacetate. In only when it came to citrate, you had a different enzyme called aconitase, whereas in case of your oxaloacetate, you have citrate synthase. In most of the cases, if you remember, if you can see, the corresponding enzyme is nothing but for example, it's like succinate, succinate dehydrogenase, malate, malate dehydrogenase. So most of the enzyme has like dehydrogenase. So it's very easy to remember. I hope this has helped you remember your Krebs cycle. Krebs cycle is very, very important at any point of your life. If you are deciding to learn your biochemistry or life sciences, so this is very important to remember and understand. I hope this has made you clear. Hello children, I hope you liked my session today. So I have made your Krebs cycle, TCA cycle or your citric acid cycle easy, isn't it? I know. So do you like my new costume? If yes, please put it look nice in my comment section. Thank you so much. Please see my other videos also, so that I can improve myself with my teaching and make you children very, very, very happy and smart like me. Smart Pluto here. Bye.